All right, thanks everyone for joining our computer vision workshop where we are using EyePop and Zapier to create a safety monitoring alert system. So for today's agenda, we're going to talk about AI and focus on computer vision models. Next, we're going to talk about how EyePop fits into the computer vision solutions. And then I'm going to show you a live demo where we have a real-time alert system where we are detecting if someone is wearing a hard hat or not. And if they are not, we are getting a alert directly to our phone. And then after, I'm going to show you how I built that model to detect the hard hats in iPop. And then following that, I'm going to show you how I built the workflow with Zapier to actually alert me once the model returns that someone is not wearing a hard hat. So what is an AI model? An AI model is a program that has been trained on a set of data to recognize certain patterns or make certain decisions without further human intervention. There are tons of different AI models, but we're going to be focusing on computer vision models. Computer vision models are trained to see and understand images or videos. So some different types of computer vision models are object detection models and classification models. Object detection models will look at an image and pinpoint exactly where the object you're trying to find is in the image by drawing these bounding boxes around the object. So here we're finding cows, and you can see that it is identifying that there's a cow and telling us exactly where it is. All right, so classification models. These models will tell you if a specific object or feature is or is not in an image. So here we have a classification model trained on different types of tumors, and it is classifying this as a pituitary tumor, and it's just telling us that it is there, not where it is like the object detection models. Key point detection models. So these identify important points on a body or object like joints or corners. You can use it to track movement or posture. And then finally, segmentation models. These models label every pixel in the image to show exactly what is what and give precise outlines rather than boxes. So you can see here it's having these precise outlines over people. It's really cool. So traditionally, to create a computer vision model, you would need to do all of these steps from choosing the correct model, pre-processing your data, normalizing it. Then you can begin to run inference, and then you need to post-process it and then make sense of your output, and then continuously maintain the deployment pipeline. That's where iPop comes in. We are a no-code platform that makes it easy to build smart computer vision models without needing to code or hire an ML team. This is what our endpoint workflow looks like. You'll come in here with your unstructured business data, your images, video, or live stream, and you'll upload it to our SDK or our web app, and then you will create your own POP. And this POP, an endpoint, will output this rich JSON data, which you can use to power your product and get your desired business outcomes. Our pipelines are low latency, and they're combinations of models working together to provide the developer with a rich set of information. And our pipelines are configurable on the fly. The combination of models can be changed without restarting the server or inference. So now I'm going to show you some models we already have on our platform, which you can use today for free if you go to our website and make an account. So we have models to detect people with 2D body points, people with 3D face, body, and hands, people in common objects, people plus animals, um, people plus devices, people plus sports equipment, people plus vehicles, text detection, vehicles and traffic cam, sports player tracking, person with demographics. And you can create your own model and combine it with any other model that I have just mentioned. So for example, here we have a eyeglass model, which we custom created, and we combined it with the person 2D model. So now we're not only detecting if someone is wearing eyeglasses and tracking the eyeglasses, but also this person and the 2D, drawing these 2D figures on them. Do we have any questions at this point? Great. So now let's focus how you can actually use computer vision to trigger real-time alerts. There are tons of use cases for this, everything from patient monitoring to workplace safety to retail and property surveillance. With iPop, you can detect anything visually, like someone not wearing a hard hat in a construction site. And then that detection, you can connect it to our Zapier plugin, which handles the alert automation. So let me show you exactly how this works. We'll run a quick live demo where we detect whether someone is wearing a hard hat and receive an alert if they are not. Um, so here I've uploaded a video and I'm going to analyze this video. And as this is analyzing, what is happening is we are sending this video to our EyePop API, and this API is going to run this video and it's going to detect hard hats. And the moment it does not find a hard hat, it's going to send me a text message. So let me actually show you what this looks like, just because the back end is a little faster than the front end because the front end is going to have to render it. So we can see that it received the video file, it's connecting to EyePop, and shortly after, it's going to um, determine whether or not it has detected a hard hat. And the moment it hasn't, there we see hard hat is missing, detected, and we get the confidence level from EyePop. And now this is triggering our Zapier workflow. So we should be getting a text message. Oh, there we go. Hard hat missing. Great. So that is how we can get that alert system working. So this is going to take a moment to process, but I actually have another tab open where it has processed. And we can see this video, and we'll see that it's detecting these hard hats. And at 5 seconds, it is detecting this worker with their hard hat missing. So we can go and check down here, and we can see that at this frame, at 5 seconds, the hard hat was missing, and it is 86% confidence, and the status is alert because we got the text message. And then we can see the server response, hard hat missing, alert sent to Zapier. So this is an example of how we can use computer vision to build a real-time alert system. So not only are we detecting something, but we are sending an alert to that person's phone. Do we have any questions at this point?
A quick question.
Yeah.
Um, so with a live feed like this, what's a general latency? You said it takes a little bit of time to process, but like how long would you consider the latency on a real time situation like this?
So the latency was more around processing the video and showing it, but you
Hmm.
could back end right how it triggered that way well before the video came to us. So the latency around detecting is minimal, but for this example of like creating that video and rendering these like bounding boxes on it, that took a little bit of time. Um, do you have like a specific example that you're thinking of?
No, I guess I'm just trying to figure out real time wise if you're sending alerts based on, let's say this use case that you're showing, which is a good one. Um, whether or not if it's like 30 seconds you get that alert or if it's an hour. Something
Yeah,
like that. So
definitely in the seconds. Yeah.
okay. Okay.
Y-
Thank you.
Yeah, of course. Any other questions?
Nope.
Yeah, I had one, sorry. When you're in this example that you're using again, which is awesome, would you have to upload a separate MP4 file, or is it possible to actually have a live feed overlaid with that detection to be able to get it in real-time alerts, or is it you have to wait for a period of recording and then upload the video to then be able to detect if there isn't a hard hat?
So you can do it through live detection. If you go to our website and make an account, and you can play around with models we already have in real time. So you can use the person with 2D, 3D models in your live camera, and you can see how fast it's running the inference all in real time. So if you were wanting to create like an alert system, it would be live, like within a matter of like seconds, you would be getting your object detection and running off the alerts. Does that answer your question or?
Yes, it does. Thank you. And then so the video feed would then just be automatically processed in real time, and then you'd get the alerts based off of that.
Yep, exactly.
Got it. All right, thanks.
Yeah, of course. Great. If there's any more questions, please send them in the chat or let me know. But now I'm going to move on and show you how I actually built this computer vision model on EyePop. And then I'm going to show you how we built the alert automation through Zapier. So if you go to our website and you don't have an account already, feel free to make one. It's free and easy to start. You'll land on this page where we're on our dashboard. And we have some different options where you can create your own model, an endpoint to integrate it directly into your app, or you can create a visual intelligence report, which is pretty sweet. But for today's demo, we're going to be creating an AI model. So once we click that, we need to name our model and define some labels. So we're going to call ours hard hat detector. I'm going to call it 2 just because I've already made one. And our labels are going to be what we are trying to detect in our image, live feed, or video. So we're trying to detect hard hats, and we're also trying to detect if a hard hat is missing. Once we do that, we just need to click continue, and we need to add some images or video files to train our model on. So I've already organized, whoops, sorry. I already have my images organized in this format where the folders names are hard hats when I have images of hard hats. And if I don't have images of hard hats, no hard hats, no hats. And this just helps the model, the platform, auto tag our images and go through and auto label them correctly using folder tagging. This takes a second to process, so I'm just going to skip to the end of what it looks like. So you'll end up in a page where it looks like this. And you can see here that we have these solid blue lines. That means that, I came in and I edited the line. But on your first run, you're going to have your images come in with these dash lines. And this is the auto labeler, making it easy for us to not have to draw these boxes manually, but actually already placing these boxes on the correct object. So it makes our task a lot more simpler because we can just then go in and approve them, just go through and just quickly run them, fly by it. If there is a hard hat missing, like this person isn't wearing a hard hat, we can approve that, but we can also ignore these images. So say, for example, we didn't want to include this image in our set, we can just hit R on our keyboard and it'll ignore that image. So once we're on this sort of stage, we can decrease our confidence threshold, and this will have the model um, reduce the model's confidence level. So now it's making many more guesses because the confidence threshold it needs to be at is only 0.04. But as we increase it, the model becomes more and more confident, and we can see that this is the object we are trying to detect. And now after running through all of these, it took me around like 35 to 45 minutes. We'll get to our last image and we'll click go to training. And we'll get a summary of all of our images. So we'll see how many images we've uploaded, how many have been approved, how many are negative examples. Negative examples are images like this, where our image that we are trying, or sorry, the object we are trying to detect isn't present. This helps train the model on what to detect and what not to detect. It gives it a more robust understanding of detecting the correct objects, and that way we don't get any false positives. So once we are on this page, we've finished labeling our model, we can click Start Training, and then our model is beginning to train. And we can test it out once it's done training. And when it is done training, we'll come back to our dashboard and we'll see it populated over here. So now from here, we have a few options of how we can use our computer vision model. If we want to use it in a React or Node SDK, we can follow these installation instructions. We can also use it in Replit, in a Replit sandbox, which is pretty awesome. All we need to do is plug in our POP ID, which is this. This is essentially telling or identifying this specific model we've created. We also have a Python SDK and a notebook plugin set up. And we also have plugins. So we have the Zapier integration, which we're going to talk about today, and also a Bubble.io and a Mind Studio integration. So to integrate into Zapier, we'll just click this. This will take us to here. And once we click this button, it is going to ask us to input our API key and our POP UUID. So our API key we can grab from up here, just view API key, but if it's your first time on the site, it'll say generate an API key. And this is our POP ID. So whichever model we want to use, we just need to grab the UUID because that is how we are identifying that specific model. And then once we enter it in, we click yes, continue to EyePop, and then we will be into our Zapier workflow. So at this point, we've created our computer vision model, we've uploaded our images, we've labeled them correctly, and then we began to train our model. So now we just need to go to Zapier. Let me show you how to set up the Zapier workflow so that you can connect your workflow to create the video, upload your video or live stream, and then send that video or live stream to EyePop and specifically to that computer vision model we just trained, so that pop. And then we will return a SMS if the computer vision detects that someone is not wearing a hard hat or not. So the first step would be to add API video to your workflow. If you click add step or when you're first creating your workflow, just type in API video. And from here, you'll be prompted to go and make an account. And once you make your account and you connect it to this workflow, it'll appear here. And then you can choose an action event. That would be when a video is uploaded to your API video dashboard. And once you upload a video there, it will appear here. You can see once you test it out, it will pull the video and it will label as video A or B. And now you've essentially connected API video to your Zapier account. And the next step would be to then connect the video, which you upload to API video, or it can be a live stream to EyePop. So API video handles uploading your video, live stream images, and we're doing this all with no code. So once you upload your video to your API video account, you will then be able to send it to EyePop. Once you make your computer vision model and your account, all you need to do is sign in and input your specific POP, which you are trying to use in your workflow. And then you can configure it. And here you will need to input the file name of the video you uploaded to API video, as well as the file ID. And all the information is there. You just need to plug and play, and then you can test it out. And then the final step is to connect this to SMS by Zapier. So we can then receive a text message once our computer vision model detects that someone is not wearing a hard hat. So to do this, you just need to make an account and you'll be given a random number or you can choose from some. And you need to put your specific message and then you can test it out. Now we're putting hard hat missing for our message because this specific workflow is for detecting missing hard hats. And whenever this workflow is going to be triggered, we can assume that iPop is detecting that someone is not wearing their hard hat. And this is all coming from the API video account, which we are using as a place to input our live stream video or images. Well, thank you guys so much for coming to our workshop. And if you don't have an iPop account already, feel free to make one and get started. It's completely free, and you can start playing around with all of these awesome models that we've talked about and create some really cool things. All right, have a great day, everybody.